after k iterations. I'll write here after k iterations. What happens, we'll see. That means what I need to do in first iteration, I'm getting 2 power 1. Second iteration 2 power 2. Third iteration 2 power 3. And in t of n by 2 power 1, second iteration n by 4 means 2 square, n by 2 power 3, like this in third iteration. Here I am getting 1 into Cn, in the second iteration 2 into Cn, here 3 into Cn. So after k iteration, what it becomes is 2 power k t of n by 2 power k plus k into Cn. Now remember one point here. What is k number of iterations? Already I told you, if n is 16, in divide and conquer, how many number of iterations it will go means it goes only log n iterations. So if it is 16 means it will divide into 8 by 8 one step. In the second step it will go for 4 and 4. The another step it will go for 2 and 2, like this. So it will go for only log n iteration. Here also it goes for k iterations, means the maximum value of k will be like, it will be from 1 to log n only. The maximum value of k is 1 to log n. So substitute what is k means log n here. What happens, you can check. So 2 power log n t of n by 2 power log n base 2 anyway, plus, of course I'll write Cn first, then log n, that is k value is log n here. Now it becomes 2 power log n base 2. So we have one concept, like I'll write here, that is x power log a base x. If both are same, I can directly write it as a. This is one formula we have. So this will become n directly into t of c, n by log n base 2. This totally becomes n now. So t of n by n plus c into n log n. So which becomes t of n by n, which is t of 1. What is t of 1? Here you can say if n equals 1, a. So here it will become a into n plus c into n log n. So if you see the maximum value, which is n plus c log n, which is n is largest, now we can say the complexity is big of n log n. Like this we can derive when it comes to methsort. Now we'll see this complexity in terms of different cases, like best case, worst case and average case. We have 3 different cases now, best case, worst case and average case. We'll see the methsort complexity in these 3 cases. Here if you consider in methsort, all these 3 cases, best case, worst case and average case, in all the cases you will find the complexity is same. Why? Because even if you give any type of order, it has to divide it into almost equal parts. Okay, it cannot differ like if you give the different arrangement. So that's why in methsort the complexity will be same for best case, worst case and average case, that is big of n into log n, which we got in this derivation. And now we'll go to the complexity of quicksort. So quicksort is also sorting algorithm which is based on partitioning only. So now we'll see what is this complexity. In best case it is n into log n. So if you observe in quicksort, what will be the best case? That means it is partitioning now, and I told you in quicksort it may or may not partition the array into equal parts. Sometimes it may partition into equal, sometimes it may not. If I take the elements totally 16, so it may partition one side 8, the other side 8, or else it may partition one side 4, other side 12. So it may happen in quicksort, whereas in methsort it may not happen. It has to divide equally. So in quicksort it may happen like this, but if it equally partitions every time it goes into the recursion, then it is called as the best case. So if it divides equal parts, definitely it is similar complexity compared with the methsort. That's why in my best case the same complexity of n into log n, same derivation will come into picture. And if you take the average case, of course first we'll go for worst case, and I have given here worst case as omega of n square. We'll see how this one. So actually in quicksort, what might be the worst case? If you observe what might be the worst case means, if I have 16 element, one side 1 element, the other side 15 elements, it will partition. Next one side 1 element, the other side 14. Like this if I go, what might be the complexity we can observe. So that's what, this is the worst case complexity. So if I observe, if I have, here I am writing, if I have n number of elements, one element one side, the other n minus 1 elements other side. One more time, one element one side, n minus 2 elements other side. Like this it will go, n minus 3 elements other side. So like this it may happen up to one element one side, 3 elements other side, one element one side, 2 elements other side, one element one side, one more element other side. Like this it may happen. If you take the complexity, I will add all the complexities, that is from n minus 1 plus n minus 2 plus n minus 3 up to like n minus 4, n minus 5, like this up to it will come to 3, 2, 1. So what is this total? Can I say it is a sum of n minus 1 numbers? So what is sum of n minus 1 numbers? N minus 1 into n by 2. So this is equals to, that is n square by 2 minus n by 2, which is, it may not exceed n square. That's why I have given bounded below function, that is omega function. So that's why in worst case we need to observe it as omega of n square. This is what we need to observe, especially if you consider quicksort. Remember this point.